applications of ordinary differential equations. Just procedure to solve differential equation by Laplace transform method. Here three important steps are there you have to follow. Take the first step 1. Take the Laplace transform of both sides of the given differential equation. Just you take the Laplace transform on both sides for the given differential equation. In second step, use some important formulas. Those formulas I will mention here. Laplace transform of y dash of t equal to s into y bar of s minus y of 0. Second formula in this, Laplace transform of y double dash of t, the formula is s square y bar of s minus s into y of 0 minus y dash of 0. Third one, Laplace transform of y triple dash of t, s cube y bar of s minus s square into y of 0 minus s into y dash of 0 minus y double dash of 0. These three formulas are very important, and here we are getting some y of 0, y dash of 0, y double dash of 0. All these things we are getting. These are nothing but initial conditions. They will give in the problem. Without initial conditions, we cannot solve the problem. Now step 3. Replace y of 0, y dash of 0, y double dash of 0 with the given initial conditions. This is the step 3, and solve by inverse Laplace transform. That's it. These three steps are very important. Then after substituting these initial conditions, then how to apply this Laplace transform, inverse Laplace transform, how to apply, how to use that one, I will explain in the problem. These three steps are only important. Now let me solve one problem on this method. Solve d square plus 4d plus 5 into y equal to 5, given that y of 0 equal to 0, y dash of 0 equal to 0. Now this is the question. Then if you want to solve this differential equation, means this is second and higher order differential equation. For this differential equation we have separate method, means you should calculate the complementary function and particular integral, and you add those two things, then it becomes general solution of the given differential equation. Means if you want to solve by general method. Now without calculating complementary function and particular integral, we will calculate the general solution of this differential equation by using Laplace transform. This is the important tool of the Laplace transform. This is very important application. Means we are solving ordinary differential equations by using Laplace transform, means without calculating by general method. Now the given differential equation can be written as y double dash plus 4y dash plus 5y equal to 5. d square y equal to d square y by dt square, that equal to y double dash. Now dy equal to dy by dt, that equals to y dash. Now according to that one, y double dash 4y dash plus 5y equal to 5. Now what is our first step in the procedure? Taking Laplace transform on both sides, we get Laplace transform of y double dash 4 into Laplace transform of y dash plus 5 into Laplace transform of y equal to Laplace transform of 5. Now, already I gave you in the second step Laplace transform of y double dash of t. Y double dash of t and y double dash both are same. Now, Laplace transform of y double dash, I am writing that formula s square Laplace transform of y. Laplace transform of y. Now, observe this one. Actually, s square y bar of s is available. Y bar of s is nothing but Laplace transform of y. That's why we are writing here Laplace transform of y only instead of y bar of s. S square Laplace transform of y minus s into y of 0 minus y dash of 0 plus 4 into s into y bar of s. But instead of y bar of s, I am writing here Laplace transform of y minus y of 0 plus 5 into Laplace transform of y only. That equal to 5 into Laplace transform of 1. Laplace transform of k equal to, that is nothing but k by s actually. Now I am writing 5 outside, Laplace transform of 1. Now you substitute, already they have given y of 0 equal to 0 and y dash of 0 equal to is also 0. Now everywhere you substitute y of 0 is 0. Y of 0 is 0, y of 0 is 0, y dash of 0 is also 0. After substituting those initial condition values, then I got like this. I am taking Laplace transform of y is also common. S square plus 4s plus 5 into Laplace transform of y equal to the RHS side. Laplace transform of 1 is nothing but 1 by s, that is 5 by s. Finally, I will modify equation like this. Laplace transform of y equal to 5 by s into s square plus 4s plus 5. Then what I am doing here, just resolving into partial fractions 1 by s. Otherwise you can apply convolution theorem also. Then by general method only we are solving here. 1 by s minus s plus 4 by s square plus 4s plus 5. By resolving into partial fractions, this is very easy problem. Directly I am taking here. If you want, you can check in rough also. Then how should I write this y? Y equal to L inverse. When you are sending L this side, L inverse of 1 by s minus s plus 4 by s square plus 4s plus 5. Then apply it for individual terms. L inverse of 1 by s. L inverse of this s plus 4 can be written as s plus 2 plus 2. I am applying here first shifting theorem actually. That's why I am writing like this. The denominator part 4s is available. Already I explained you first shifting theorem. S plus 2 whole square. S plus 2 whole square means s square plus 4s plus 4. The remaining is but actually here 5 is available. Then that's why the extra part is 1. Now 1 minus the L inverse of 1 by s is 1 minus s plus 2. Instead of s plus 2 e power minus 2 2t. The concept of first shifting theorem already I explained you. The remaining is, what is that? L inverse of s plus 2 by s square plus 1. Then 1 minus e power minus 2t. L inverse of 1 by s square plus 1. 2 by s square plus 1. I am separating here. 1 minus e power minus 2t. The L inverse of this one is cos t. L inverse of the second part is 2 by s square plus 1 is 2 sin t. Like this, we can solve the problem. Here d is nothing but d by dt. Actually dt square here. This is dt square. Previously I told you dy by dx, that is d square y by dt square. Or if it is independent variable x, then you can calculate in terms of x. Now